Okay, let's get started. So, do you have any questions so far? Okay. Yes.
Sorry to have to pick the right patches might be related to the last lesson also. First, I would like to ask, in a big data set, how could we choose an explanatory variable for our model?
In a big data set,
Yes, for example, like the data set of platform you provided us, how can we choose the explanatory variable among all of the variables that we have?
you're talking about modeling, right?
Yes.
Well, usually we will use as much data as we can to do the predicting variable. Okay. You have a target variable, right? For our purpose, we want to predict the buying probability and expected buying amount, right? So all of the variables, all of the other variables that you can collect from the data, you can use them for predicting. Okay.
So you mean that?
The point is like we try to get the information from all of the data we have to make the prediction. Okay. So the answer would be the more explaining variable, the better.
Then I would like to ask, will it be overfitting the model?
Yeah, there could be some overfitting problem, but with the data we have so far, we will not see the problem yet. Okay, you will get into like overfitting type of situation when you learned big data, when you learned machine learning. Okay, when you are using big data, you might have like 1,000 explaining variable. Okay, that could be a problem. Okay, that you would run into the situation of overfitting. But the Tafang data set that we are using, we are talking about like less than 10 explaining variable, right? It's not likely that we will have overfitting problem here. Okay, so overfitting is yes, it will be a problem, but it's actually not in the scope that we can cover in our course. Okay.
But from previous lesson, you just like create a model to predict the revenue, the buying power of customer based on the recency and similarity. So from that model, can you explain how can you extract and calculate the purchase cost probability to in the market, cost and effect of marketing instrument?
Okay, so the cause and effect of marketing instrument cannot be estimated from the model. Okay, so that's why we are doing the cost effective of the instrument by assumption today, right? So take a look at here. Okay, now we want to combine the prediction, which is the expected buying probability and the amount of and the expected buying amount, right?
Yes,
From the model we have these two columns, right? These are from the prediction of the model, but this is nothing to do with the cost effectiveness of the marketing instrument, right? These are the probability and buying amount that if I do nothing, right? Okay, if everything are the same as last month, then I can expect that the buying probability of this customer will be this much, and the buying amount will be this much next period. Okay, without marketing instrument. Okay? Now today we are going to like add in the effect of the marketing instrument. Okay? And we know that the effect of the marketing instrument, okay, it depends on the intensity of the instrument, right? And also the characteristic of that instrument, right? Okay? So we want to combine the prediction and assumption before we can evaluate the expected incremental profit, net of cost, okay, for every customer, right? That's what we are going to do today, okay? Prediction is from the model, okay? And the assumption is, this is a general assumption, right? And after we know the characteristic of the instrument, and we can optimize the cost, right, to get the best effect. Okay. So this is the mathematical form, but in order to realize this mathematical form in R, it's actually very, very easy. It's like just 2 lines of code. Okay. So basically, first of all, we have this S-curve encapsulated in a function called capital DP, right? So in this DP, you just place X as the cost of the coupon, right? The face value of coupon. And MBA is the characteristic of the instrument, right? So assuming that our MBA is 0.2, 25, 40, okay? And assuming that we are using a face value of 30, right? This is the way that we can calculate the net expected payoff for each of the customer. Okay? As you can see that, first of all, these are the S-curve, right? These are the cost-effective function of that instrument, isn't it? Okay? So given M, B, A, and X, I actually has a delta P, okay? And why should I do this? Because the delta P is actually kept by 1, right? Okay? See that? So this delta P would be like depending on the, as you can see that I'm using this column, right? Okay? And what is this column? Yeah, for every customer, right? So for every customer, I'm like, kind of like, their increment, if I use an instrument of MBA, of this MBA with X30, right? If I'm doing this to all of our customers, right? Their probability, their increment on probability would be like either this one, okay, or this one, isn't it? The minimum of the two, right? This is from the S-curve assumption, and this is actually kept the probability at 1. You get the point? Okay? So DP, this is actually to like implement this condition. Okay? So the mathematical condition is like kind of complicated, but when it go down to R, it's like just 1 line of code. Okay? Now you know the DP. DP would be a vector, right? It would be a vector. And then we see multiplied by the amount, multiply the margin. Margin is like Usually you get it from your accounting department, right? And then we minus the cost, right? So this would be ER, would be the expected return, the expected net payoff when I apply this instrument to all of the customer, all of the existing customer, right? So ER would also be a vector, right? Okay? And this is the distribution of ER, as you can see. Okay? Let's go to R. Now let's assume the margin and let's run this up. Okay, let me. As you can see, that B is actually a data frame of this many customer, right? So when I do this and do this, see, I have the DP of, DP is actually a vector. See that? Right? It's delta P, and then ER, sorry. I can look at margin. So ER is another vector, right? Okay? So the first customer, the net expected profit is actually negative, right? The second customer is also negative. You see that? Right? Okay?
Professor, what does that mean?
It means that if we use this instrument, apply this instrument on this customer, the net expected payoff is negative. It's not worthy to apply this instrument to this customer. That's what it means. Okay? So if you really have a instrument and the characteristic of the instrument is like this, right? And you set the face value to 30, okay? So you will have a lot of, as you can see that in this histogram, you actually will have a lot of customer that is not worthy to do this instrument, right? Okay, so let's do some exercise. Okay, I already give the answer here, right? Okay, but let's try to answer this question, right? With DP and ER, right? These two vectors you already have, okay? How can we know how many customer should we apply this instrument? I mean, I want to apply this instrument to the customer who has the net expected payoff larger than 0, right? Okay, so how many people's ER is larger than 0, right? That is the question. So as you can see that about about 3/4 of the customer are below 0, right? Only about 1/4 of the customer are good to apply this instrument, isn't it? Right? That is the reason that you want to do the simulation and calculation. Okay? That if you are a marketer, now you know that this instrument cannot apply to all of the people. Some people you can apply, some people you cannot. You see that? Okay. So how many people we can apply this instrument? It's easy, right? I just test ER larger than 0 and do a sum, right? Okay? So I know that out of the 28,000 customer, only about 7.2 thousand will have a positive payoff when I apply this instrument. Okay? Now, what is the expected return if we apply the instrument to all customer? It's easy, right? I just sum it up, right? Okay. I sum it up. I'll say that if I apply this instrument to all of the customer, I would end up lose like 203,000. Okay, I lost a lot of money. See? Okay. Now, what is the expected return if I only apply it to those who have positive return? Okay. That is the important problem, right? So I select a group of people. I only apply the tool to that group of people, right? So how can I do the selection? I use indexing, right? Okay. I use this condition expression as the index, right? So out of ER, I only choose those ER that who are larger than 0, right? And then I sum it up. So if I apply this tool to selective customer, I will have a positive net payoff of 75.8 thousand. You see that? This is the reason why we want to do the model, right? If you're doing the model and then you just do the prediction, it's not useful for you at all, okay? But you have the model, you have the prediction, and you know the cost effectiveness of your marketing instrument. You can do this type of calculation that tell you how to choose your target customer to maximize your outcome. Okay? Yeah. Problem? Question?
Once we know the expected return of customers who can give us a positive revenue, then can we also decide if we made the money back from using the coupon? Because we must have spent a marketing budget because the coupon has face value.
Right, you already deduct the cost of the coupon here, right? Okay? So this is net payoff. Okay, now the next thing we want to know is that at this point we set the face value at 30, right? How do we know that 30 is a good value? What happened if right?
Is it possible then to put a range?
Yes, that's what we are going to do now. That's called simulation, right? Now I want to simulate that with this marketing tool, if I change the face value, how is the result? How is the outcome will change with the face value of this instrument? Okay, that's what we are going to simulate right now. Get me? Okay. So, which is not too difficult to do, right? Okay. Again, we have the MVA, right? We have the MVA, and then X. Now, instead of a single value, now I define X as a sequence from 10, 11, 12, up to 45. Okay? You know this function, right? Sequence.
So it is only an integer, it doesn't become a fraction. It is 10 and 11, it is not 10.1 or 10.2.
Well, it actually controlled by the step, right?
Okay,
The step is 1, then it will increase by 1, right? So this sequence is like, so X, this is the value of X. It's no longer a single value, now it becomes a vector. You get me? Okay. Now when and then I simply like encapsulate the 2 lines of code, right? This 2 lines of code in an S-apply, right? I encapsulate the 2 lines of code in S-apply. See that? okay? And then I apply this function to each element of x. This is x, right? So I'm doing the same calculation for each one of x, okay? And at the end of the function, I output a few things, right? This is x. This is the sum of ER, which means that if I apply the tool to all of the customer, okay? And this is the number of customer who has the net payoff larger than 0, n, right? And this is the outcome if I only apply to the profitable customer, okay? So I have this 4 things, 4 outcomes at the end of the function, okay? And I like transfer it into a data frame, okay? So let's see, let me run this and let's take a look at the data frame. Now in the data frame, see, you have let me do it here first. So now the data frame, as you can see, I have an x. This is the face value. This is when I apply to e-returns, I apply to all of the customer, right? And this is the number of customer that has a positive outcome, okay? And this is the value that I only apply. So if the face value is 10, it's not useful at all, right? Because no one is actually seeing a positive payoff yet, right? It's too low. It's no effect, right? So, but as long as the x come to this range, you will see that the number of positive customer, profitable customers start to increase, right? Okay, so it's actually very easy to like if you have this this number, right, you can actually do some. If I do a GG plot, and as you can see that the x, the horizontal axis is actually the cost, right? X. So x would change from 10 to like 50, okay? And as you can see that the if I apply the tool to all of the customers, it's like I always has a negative payoff, right? So but if I do it selectively, okay, I actually can have a optimized the outcome about x at like 35 something, right? When I set actually I can look into the df, it would be easier. So when I set x at 34, okay, I can apply the tool to like this many of customer, and I will have maximum the net payoff of 39,000. You get me? Okay. So this is the way, right, that we can, given the S curve, I actually can optimize X to get the maximum expected outcome. See that? So this is the logic, right? Still, you need to do assumption on MBA, okay? But as long as you know the MBA, you actually can, first of all, you know what is the optimum X, okay? Second, you know how many customer, which customer you should apply this instrument, okay? And third, you know that when you apply this amount, when you apply the coupon at this amount to this group of customer, the expected outcome is how much, okay? And that is basically these three things, right? The three things that we have done so far. We choose the X, right? Optimum X, okay? We choose a group of customer, right? Those who has expected payoff larger than 0, and then you know the effect, right? So these are the things. The combining prediction and assumption and using the simulation technique, right? Applying the simulation technique, we can find the optimized result.
Professor, does this mean that we give the marketing instrument, for example, a coupon, only to customers who have a positive expected revenue?
Yes, yes. You should do that, right? You should do that, okay? Right? Because when we are doing business, we are always looking for the maximum expected outcome, right? Okay. So this is basically what we are doing, right? Okay. And this is basically how this part of the chart works. Okay? You get me? Question? Yeah.
But Professor, since you've done everything, then what do we do in the final?
That's what I want to explain. We have not done everything yet. We have more to do. Okay? Okay? This is just the basic logic, okay? That we can combine prediction and assumption to optimize our outcome, right? Okay? Now, up to this point of time, we are fixing M, B, and A, right? This MBA is fixed, right? Okay. How about you have a multiple MBA, right? For example, you have multiple instruments, so you have every instrument it has its MBA, different, or another possibility is that the same instrument can have different MBA for different group of people, right? Isn't it? Okay. So if you have like for example here in this example, I have 4 MBA, which is our 4 different marketing instruments. Okay. Assuming that the MBA apply to all of the customer again. Okay. So you have 4 MBA, so I define the MBA in the vector, okay? So this is MBA 1, MBA 2, MBA 3, and MBA 4. See that? So I'm using index to and define the MBA as a vector, okay? Again, I'm doing the X as a sequence, okay? Now again, well actually I in this code I simply plot the S curve, okay? I do not do the simulation yet, okay? I just plot the S curve of this 4 instrument, okay? As you can see that the instrument 3 is like less effective, right? It's cheaper, right? Because its position is on the left, right? So it's cheaper, but its effect is lower, right? And these things are more expensive and they have a better effect, right? Okay, so they are different MVA, and I just in this part I just like draw the S curve. This is not simulation yet, okay? It's just assumption, okay? The four assumption. Now, based on the four assumption, again, see. These are the code that we are using for single MVA simulation, okay? So, but now we have 4 MVA, right? So out of the S apply, I put the L apply. See that? Okay. So I'm applying the length of MM. MM is like this one, right? So it's like 1, 2, 3, 4. So the first time the S apply execute, it will use MVA1, MM1, BB1, AA1, okay, which is this 3, okay? And the second time that the L apply run, it will like do it like in this 3, okay? So by encapsulating the code to like 4 instruments, okay? Like I can do the simulation and actually plot the result, okay? Let's see the code. See, now, after I do do this code, I will actually have a data frame, okay? And in this data frame, a little bit different, right? Because this instrument 1 and the X change from 10 to 60, and then instrument 2, X change from 10 to like, again, change to 10 to 60. You see that? Okay. So after this code, I actually simulate 4 instruments and put the result in the same data frame. Okay? And then I can use ggplot to compare the result of all of these instruments, right? See that this is the EO. It means that if I apply to there are 4 instruments, right? By represented by 4 different colors. See that? Okay. So, but no matter which instrument I choose, if I apply the instrument to all of the customer, I will not make money at all. You see that? Okay? Because 0 is here, right? So if I, no matter which instrument I use, if I apply the instrument to all customers, I would not make it. I would not make money. Okay? But however, if I do it selectively, as you can see that I see positive profit already. All right, the unit here is K, right? So if I do it this instrument 3, right? Blue is instrument 3. So if I do instrument 3 and I apply to like if I set X at 22, I will have about more than 100K of profit. See? Okay? And if I do like instrument 2, I can have and I set the x value at 40, okay? I can have a profit of 143K. See that? Okay. Now this is the way that if you have like multiple instrument, then you can like simulate them together and compare their result, put it in the same chart so you can compare them, right? Okay. So so if you are a marketer, right? Okay. So which instrument will you choose?
Green. Instrument 2.
The green one? Is there any other answer? Are you always choosing the highest one? No, why?
You have to look at the margin.
This is already by looking into the margin, you are talking about the cost, right? In order to get the profit of 143, what is the cost that I want to spend, right? How to calculate the cost? Is anyone?
Cost of what?
Cost of marketing, right? You're kind of like doing marketing, like doing investment, right? So you need to spend money before you get the return, right?
But we've already subtracted that from the.
Yes, you subtract it afterward, right? But before you do that, you need to allocate the budget. You need to have the capital to run the marketing, right? So what is the cost if I want to do the things?
40 into the number of customers.
Yeah, and the number of customers here, right? Because I want to set X at 40, okay? So how many customers will I use?
878.
Okay, so what is the cost? It's 40 multiplied by A7A3, right? That is the capital that I need to prepare before I can run this marketing instrument, right? But let us see here. Now, for this one, what is the cost? Because I want to use the maximum output, right? So this maximum output is here. See? Okay. It's about X is 22, right? So X is 22 is here. It's about here, right? So you need to spend $22 on 10880 customer. Okay? That is your investment. You need to spend that investment in order to get this expected payoff. Yeah.
In the last graph, the third graph, what is the scale on the y-axis? What is 9,000?
It was just N unity. It's the number of customers, right? It's the number of customers. Okay? So N is the number of customers. ER select is the expected return that if we apply this instrument to the selective customer. Okay? That's the two things. Okay? So put that in graph is good, right? But the better way to do this is like, do you know what that means? If I have DF, right? Okay, so I don't really need to draw the beautiful graph here because actually making a graph it's actually pretty pretty well, it's interesting if you know how to do that. It's interesting and but it actually have a lot of effort to do that. If you are only interested in for each of the instrument, okay, for each of the eye, you want to know, you want to pick up the column, you want to pick up a column that, you want to pick up the row, the record that has the largest selective net payoff, right? This is the comment, right? I group DF by I, right? And I select I select one record with the largest ER select, okay? What does that mean?
Highest payoff.
Yeah, highest selective payoff. So as you can see that for instrument 1, the optimum strategy is X34. And I apply it to like this many customer, okay? And I will have expected return, okay? This is 2. And so what is the best face value for instrument 4?
Sorry?
What is the best face value of instrument 4?
43.
Yeah, it's 43, right? And so if I set the face value at 43, how many customer should I apply?
697.
Yeah, 6979, right? And what is the expected outcome? This is the expected outcome, right? Now we actually has the now we actually complete all of this the entire business process, right? Up to this point, right? You see that? We use model to do prediction, okay? And we do some reasonable and flexible assumption, okay? And with this prediction and assumption, we actually can define multiple strategy, multiple okay. How? Okay, so we have the prediction and we have the reasonable and flexible assumption. And with this flexibility, we actually can compare multiple alternative operations, right? And for each of the operation, we can find its optimum parameters, right? For each of the coupon, we want to know the optimum face value, for example, okay? So, and then we can compare the expected return of each of this instrument, right? So we can allocate our marketing budget, right? So at the end, the process of business analytics is to help us make the decision to get the best outcome, right? Under uncertainty. Okay? Okay? So how do we cope with this uncertainty? In the one hand, we are using model to do prediction. Okay? In the other hand, we use our sense of business, use our domain knowledge to do reasonable and flexible assumption. okay? And then combine the two, use some programming, okay? Then we can combine the logic to help us make the best decision. And again, what is the best decision?
Maximum profit.
Can you say it more precisely?
Like after maximum profit in a way that is within our budget.
Right. You should say that we are making decision with uncertainty, right? So now, with the uncertainty, we cope with this uncertainty with prediction, with assumption, right? So under the uncertainty, we want to find the alternative that lead to the maximum expected outcome, right? It's not certain outcome yet. It's the maximum expected outcome. Okay? And that is what we have learned in the whole semester. Okay? And then I want you to apply that to your final presentation. Okay? And how to do that? Let's cover it in next hour. Okay? Let's take a 10 minutes break. We'll be back at 10 after 11. Okay?